We all feel it, right? Gravity, that constant pull keeping our feet on the ground. But what if I told you that whole idea is wrong? What if there's no force pulling you down at all? And what we call gravity is actually an illusion created by the warping of time itself. Yeah, get ready because we're about to dive into one of Einstein's most elegant and truly mind-bending ideas. But hold on. Right away, this beautifully simple idea slams into a huge problem. I mean, if the ground beneath your feet is constantly accelerating upwards to meet you, then why isn't the whole planet blowing up like a balloon? This paradox, this seemingly impossible question, is actually the key to understanding everything. So first, let's really unpack Einstein's radical idea and the massive paradox it seems to create. For centuries, we all just accepted Newton's view. There's this mysterious force that pulls an apple from a tree to the ground. Simple enough. But Einstein came along and proposed something way simpler and way weirder. He said, what if there is no force? What if that apple is just floating in space, perfectly still? And it's the ground that's actually accelerating up to hit it. This is his famous principle of equivalence. Now, I know what you're thinking. You've probably seen that bowling ball on a rubber sheet analogy a million times. We're gonna just set that aside for now. Honestly, it's a pretty flawed model because it ends up using gravity to explain gravity. It's circular. To really see what's going on, we're gonna need a much better, much more accurate way to visualize this. So, what's the first clue that starts to unravel our paradox? Well, it starts with light. Think about it. If you're in an accelerating elevator and you shine a flashlight across, the beam would appear to curve downwards as the floor rushes up. And if gravity is just acceleration, then it stands to reason that gravity itself must bend light. And here we go. Here's the next paradox. For light to follow a curved path, the light on the outside edge of the curve has to travel a longer distance than the light on the inside of the curve. And it has to do it in the same amount of time. Well, that would mean light is traveling at different speeds. And that breaks one of Einstein's own most fundamental, unbreakable rules. The speed of light is constant for everyone. No exceptions. So, how did Einstein solve this mess? He's painted himself into a corner. To get out, he didn't change his rule about the speed of light. Nope. He did something far more radical. He changed the very nature of time itself. How can light travel a longer distance at the exact same speed? Well, there's only one way. You have to give it more time to make the journey. Einstein had a flash of genius. Maybe the light on that outer path isn't traveling faster. Maybe time itself is running faster for it, further away from the ground. And this is it. This is the revolutionary concept of gravitational time dilation. It turns out that mass doesn't just pull on things. It literally warps the flow of time around it. Clocks closer to the Earth tick just a little bit slower than clocks that are higher up. Time literally runs at different speeds at different altitudes. And believe me, this isn't just some abstract theory. It's a real physical thing that's happening to you right now. Because your head is slightly farther from the center of the Earth than your feet are, it is aging just a tiny bit faster. We're talking a minuscule difference, but that tiny difference is the absolute key to solving our big paradox. And we have proof. We're not just taking his word for it. Experiments like the Pound-Repka experiment showed that light actually loses energy. It redshifts as it climbs out of a gravitational field. That's a direct confirmation of time dilation. And today, the GPS satellites orbiting our planet have to constantly correct their clocks because their clocks run faster up there than ours do down here. If they didn't make those corrections, your GPS would be totally useless in a matter of hours. Okay, so we've established it. Time is warped by mass. But how does that solve the expanding Earth problem? To really get that, we need a better way to visualize spacetime. Forget the rubber sheet, let's build something new. So let's do a little thought experiment. Imagine a flat piece of paper. This is our flat spacetime. Now let's roll it into a cylinder, where moving around the cylinder represents the flow of time. So far, so good. Now let's add the Earth. Because of time dilation, we know that time runs slower near the Earth's surface. To show this on our model, the circumference of our cylinder has to get wider where time is slower. And as we do that, our cylinder gradually transforms into the shape of a cone. And it's super important to remember, this cone isn't just a neat visual trick. This geometric shape, this cone, is the curvature of time caused by the Earth's mass. This is the actual arena where all motion really happens. Okay, we have our model of warped time. So now let's use it to finally, once and for all, solve that crazy expanding Earth paradox. Now, in this curved spacetime, an object that's at rest, like the ground, is simply moving through time. On our cone model, that path is just a straight line drawn right along the surface of the cone. From this perspective, the ground isn't accelerating at all. It's just following a perfectly straight, natural path. But here is the big reveal. This is the magic. What happens when we take our cone and unroll it back into a flat piece of paper, back to our old flat way of looking at spacetime? That perfectly straight line on the cone is now a curve. And what does a curved path on a spacetime diagram mean? It means acceleration. The ground is accelerating upwards. Both things are true at the same time. So here's how it all clicks together. The curvature of time allows the ground to constantly accelerate upwards on all sides of the Earth. But, and this is the genius part, within that curved time, the physical distance between any 2 points on the ground stays exactly the same. So the Earth doesn't expand. And that falling apple, it's just following its own straight line through this very same curved spacetime. We only think it's accelerating because we are the ones stuck on the accelerating ground looking at it from our warped perspective. So the next time you feel your feet planted firmly on the ground, just remember what's really happening. It's not some mysterious force pulling you down. It is the ground accelerating up through curved time to meet you. The everyday feeling of gravity is almost entirely because of this warping of time. So you have to ask yourself, is gravity even real? Or is it just the shape of time itself?